Dear students, in this video we are going to see about the layout of modern steam power plant. A steam power plant must have the following equipments. First one is a furnace to burn the fuel, steam generator or boiler containing water. Heat generated in the furnace is utilized to convert water into steam. Main power unit such as engine or turbine to use the heat energy of steam and perform work. In this setup we are going to use turbine as the prime mover, and another last one is piping system to convey steam and water. So the arrow lines shown in this diagram are the various piping system to convey steam and water to the entire area. Okay, the four main circuits involved in this steam power plant are coal and ash circuit. Second one is air and gas circuit. Third one is feed water and steam flow circuit. And the last one is cooling water circuit. Okay, let us see coal and ash circuit. This circuit consists of coal storage unit, ash storage unit, coal handling system, that is this is the coal handling system or plant, and this one is ash handling plant. The handling system consists of belt conveyors, screw conveyors, etc. to convey the coal and ash from to the boiler and from the boiler respectively. So coal arrives at the storage yard and after necessary handling, passing on to the furnace after kind of pulverizing process, it is transferred to the boiler through the fuel feeding device. Ash resulting from the combustion of coal collects at the back of the boiler and is removed to the ash storage yard through ash handling equipment. In general, the Indian coal contains 30 to 40% of ash, and a power plant of 100 megawatt produces normally 20 to 25 tons of hot ash per hour. So this is the first circuit: coal storage, coal handling plant, boiler, ash handling plant, ash storage. So second one is air and gas circuit. So this circuit consists of air filter. So from the atmosphere, the air will be supplied through air filter, air preheater, dust collector, and chimney. So air is taken from the atmosphere to the air preheater through the action of a forced or induced draught fan, or by using both. The dust from the air is removed by means of air filter. Here air filter is not shown, but the atmospheric air may contain contaminations of foreign agents. It has to be filtered out. So it is removed by means of using air filter before supplying to the combustion chamber. The exhaust gas carrying sufficient quantity of heat and ash are passed through the air preheater, where the exhaust heat of the gases is given to the air and then it is passed through the dust collectors. It is a kind of superheater in automobile IC engine. So the exhaust gas from the burner is used to preheat the atmospheric air, and then it is passed through the dust collectors, where most of the dust is removed before exhausting the gases to the atmosphere through chimney. So you have to keep it in your mind that the atmospheric air containing the contaminations has to be filtered. By the same time, the exhaust gases having contaminations also has to be filtered before sending it into the atmosphere. Fine. So next one is feed water and steam flow circuit. So third one is feed water and steam flow circuit. So this circuit consists of a boiler feed pump. So this is a boiler feed pump. So this one is the boiler feed pump, turbine, and feed heaters. So various feed heaters will be installed. Superheater kind of heaters are installed in this setup. So the steam generated in the boiler is fed into the steam prime mover to develop the power. The steam prime mover here is the turbine. So the steam coming out of the prime mover is condensed This is the condenser. The steam coming out of the prime mover, that is turbine, is condensed in the condenser and then feed to the boiler with the help of pump. So this is the extraction pump. It has to be feed into the boiler. The condensate is heated in the feed heaters using the steam tapped from the different points of the turbine. The feed heaters may be of mixed type or indirect heating type. Some of the steam and water is lost passing through the different components of the system. Therefore, the feed water is supplied from external source to compensate this loss. So the final one is uh, cooling water circuit. So this circuit consists of a circulating water pump, cooling water pump, and cooling tower. So here the cooling tower is not shown. So this is the cooling tower. It is a kind of chimney-like structure. Cooling tower will be like a chimney-like structure, but it is shown like a circle here. So the cooling tower. So the quantity of cooling water required to condense the steam is considerably large, and it is taken from lake or a sea or river. The cooling water is taken from the upper side of the river. It is passed through the condenser. So this is the condenser, and the heated water is discharged to the lower side of the river. Such system of cooling water supply is possible if adequate cooling water is available through the air. Okay, let us see the working of thermal power plant. We have seen the various circuits, four circuits involved in steam power plant, and now we are going to see the working of thermal power plant. So the steam is generated in the boiler. So this is the boiler where the steam is generated. The thermal power plant using the heat of fuel burned in the combustion chamber. The steam generated is passed through the steam turbine. So this is the steam turbine. So whatever the steam generated in the boiler will be sent to the steam turbine, where part of its thermal energy is converted into mechanical energy, that is rotary mechanical energy, which is further used for generating electric power. So the steam coming out of the steam turbine is condensed. So the exhaust, it is a kind of exhaust from the turbine, will be condensed in the condenser, and then the condensate is supplied back to the boiler with the help of feed pump. So it has to be sent to the boiler with the help of feed pump, and the cycle is repeated. So the function of the boiler is to generate the heat, steam. It is the ultimate aim of this boiler. So the boiler has to generate steam, and the steam has to be supplied to the turbine to rotate the turbine. From the rotational energy, that is the mechanical energy, electrical energy will be generated by the means of generator. So the function of condenser is to condensate the steam coming out of the steam turbine at low pressure. The function of the steam turbine is to convert the part of heat energy of the steam into mechanical energy. The function of the pump is to raise the pressure of the condensate from the condenser pressure. So here the extraction pump is placed right. So the function of this pump is to raise the pressure of the condensate from the condenser pressure. It may be from 0.015 bar to 200 bar. So the other components like economizer, this is the economizer, so superheater and steam feed heaters are used in the primary circuit to increase the overall efficiency of the thermal power plant. So it is having a higher efficiency, and the cost of the steam power plant installation cost will be comparatively low, and it is having ability to burn coal, especially high hash content inferior coals. So by using a steam power plant, if we are going with the hydel power plant, we have to use plenty of water. So the plenty of water availability is required. So here the requirement of water is less, and it is highly reliable and higher efficient compared with any other type of power plants. So the it is 100%. If this question is asked in an university, it will be asked in 13 marks. So the circuit diagram is must, and they have to explain the four circuits involved in a steam power plant, and working principle, character,